Hi everyone, and welcome to my talk about APIs, testing, validation, contracts, and API development. I hope that everyone can see me and hear me, because at the moment I'm not able to see the chat, but I will see it when we get to the questions section. So, my name is ATANAS, and here's a bit of info about myself. I am a senior software engineer at Schwartz IT, and I work in the IT Solutions Development Department. I'm part of a team which develops and maintains our CMS for our property management, among other systems. And why am I talking about this topic today? So basically, I was given a task which I finished quicker than usual, and I was crying out for work. And my colleagues gave me a new task, I guess as a bit of a challenge and as a bit of a joke, me being unaware. It was something they attempted to solve a couple of years ago, but were unable to do so, and for a good reason. The technology wasn't quite there yet, and it's still not quite there and not as particularly stable as we would want it to be. But after a lot of hard work, I was able to solve it, and I'm here to tell you about it. Now, at the time, to the best of my knowledge, it was only us at Schwartz and only very few other companies which were using this technology in this particular way. It's only in the past couple of months that I've seen other companies adopting it and a few GitHub repos popping out here and there. Very few of them are actually talking about it. There are very few blog posts or tutorials, so I wanted to share my findings with you because I think they're immediately applicable and useful in practice. So a quick look at the agenda. We'll cover some basics, as I want this talk to be accessible at all levels. We'll then see design first versus code first and how that applies to API development. And we'll see what is an API contract and why API first is so important. We'll go over contract testing and the tools needed for that, and we'll tie this whole thing neatly into a knot with a live demo. Introduction. So first, a bit of a joke. If you came here for the IPAs, you're in the right place, but the wrong time. APIs now and IPAs later. And first, a small disclosure. I'll be using the following presenting technique I learned from the Head First books and an ex-colleague of mine to keep your brains focused. The presentation has more text than usual, but that's intentional, as when I'm rewatching a presentation, I like to pause and read the slides. So it's not a bug, it's a feature. I'll randomly show you slides with wolf facts and photos throughout the presentation. This is a brain focus technique to give your brains a bit of a breather and then to bring your focus right back into the presentation. The wolf is a noble creature and it's driven to extinction in many parts of the world. And I personally have done a small donation to the Euronatur German charity, as one of its doings is protecting the wolves in Europe. When I donate to charities, I don't tend to stick to any particular one. I just chose this one because I'm using wolves in the presentations. So let's get started. First of all, what is an API? An API stands for an application programming interface, and it's a connection between computers or between computer programs. A document or a standard which describes how to build an API is set to implement an API specification, and a computer system or software which implements it is set to expose an API. Each time you use an app on your phone like Facebook or check the weather, you're using an API. And to explain this a little bit better, let's think of a familiar example with the restaurant. So in this case, you can think of the waiters as your APIs or the messengers, which take your request or your order to the kitchen, which is the server, which prepares your food. And then the waiters deliver back the response, in this case, which is your food. So I hope that makes it clearer. Now, imagine you're in a team that's building Twitter, and you have a front end and a back end, and they need to talk to each other, so that the front end can display the tweets which are stored in the back end, in a database, for example. Now, you need to build them in parallel, not wait for the front end or the back end to be built first. The connection between them happens over APIs. And in the previous slide, we mentioned that such a connection is normally described by a document, which is called an API specification. You're given such a document, and both teams set off to build the software according to this document. Now, if they adhere to the document, when they go live, their APIs will be able to talk to each other. But if intentionally or by mistake they don't adhere to the document, their APIs won't be able to talk to each other when they go to production, and they'll have bugs. This is where OpenAPI and contract validation comes in. It's a way to enforce API contracts or API specifications. Now, in the current situation of increased remote working, A simple medium like an OpenAPI specification document is indispensable in meeting your requirements when building APIs. Things get even more exciting when such a document can serve as a contract, generate clients, servers, documentation in a plethora of languages, put your developers first and clients as well, have automatic fail-fast validation, is cross-platform and language agnostic, is both human and machine readable in YAML or JSON, and speeds up development, prototyping, and reduces costs. And let's see how all of that happens. So when building software, there are several approaches you can take. First, let's look at a high-level design first versus code first development. Now, with the code first approach, you normally start in your IDE typing out some code, and somewhere at the back of your mind, you know that eventually you have to build an interface to deliver this software. However, your main focus is on the core functionality and not the interface. When the time comes to implement the interface, the core service is pretty much mostly done, so it drives the implementation rather than the other way around. And to the end user, the client, this might feel like it was tacked on, like it wasn't developed very well, like an afterthought to the core service. It's usually encountered in synchronous flows, such as the waterfall model, and delays at any point in time will push back the overall delivery of the product because a lot of time and effort has already been sunk in. Now, in comparison, with an API-first approach, instead of starting with the code, you start with planning mocks and tests of the API. This process is aligned with agile software development, so it allows the team and any stakeholders, technical and non-technical, to weigh in on the process and direction functionality early and often, before a lot of time and effort and money has been sunk into the project. Now, like any product, the concept of an API usually starts with identifying an opportunity. From there are two possibilities that you can develop the API. The design first approach, where you design the API contract first before writing any code, and the plan is converted to human or machine readable contract, such as an OpenAPI document from which the code is built. And then you have the code first approach on the other hand, based on a business plan. You start directly coding the API, from which then later on you can decide to build documentation or maybe generate a Swagger documentation. Random wolf fact. So, true love. Once a wolf has found a mate, they tend to stay together for better or worse, through sickness and health, often till death do them part. They have been known to sacrifice themselves for the survival of other wolves. So, move over, Romeo and Juliet, there's a new couple in town. Choosing the right approach for your API. So there are advantages and disadvantages with both approaches. And in the end, choosing the right one boils down to your immediate technological and strategic needs. First, let's look at some negatives of the code-first approach. So the code-first approach doesn't mean leaving out the design. What it means is that the design is hidden away in Jira tickets, Confluence pages, text documents, and potentially lost to time and history forever. This can lead to some potential problems, though. You can have frustrated users, you can build the wrong thing, you can miss opportunities if no one knows about your API and you don't have any documentation. So now let's look at some good use cases of the code-first approach. When delivery speed matters, so you can start coding right away, which obviously speeds up development, and when developing internal APIs. If you're developing something small just for your team or your company and you know who's going to be using it, then probably that's the ideal approach for you. And now let's look at some of the negatives for the design-first approach. So it's hard work. To be honest, it takes a lot of hard work for any team to move to design-first approach. And also it takes commitment. Companies must be intentional, no matter their size, big or small. The shift to design-first doesn't happen on its own, and it doesn't happen overnight. Now, let's concentrate on the benefits of the design-first approach, which far outweigh the challenges. So you get product-driven APIs, you get to work in parallel, you get much shorter feedback loops because you can see what fails and where it fails, and you can try the code before it's delivered. You can look at the API contract as a source of truth for DevOps, for integration and deployment, etc. And when delivering mission-critical APIs. So if your clients of your API are external, a good developer experience matters. Random wolf fact. It's all in the howl. Wolves do howl at night, and these soulful calls have nothing to do with the moon, like most people think. Their penetrating, hauntingly beautiful howl is a primary communication tool, both between lone wolves and their pack, and between packs as well. API first. So we can already see that the design first or API first is the better approach. But why? In a world where speed to market holds premium, why would you spend valuable building time to focus on designing the API first. Is it worth it? There are several benefits for choosing this approach, which potentially outweigh delaying your time to market. Earlier validation, clearer abstraction layer, decoupling dependencies, ensuring the quality, predictability, and stability to withstand web clients, mobile clients, and other developers as well. So a couple of real-world examples for this. So Twilio has an API-first cloud platform, which is tailor-made to support their customers and partners. Speaking from personal experience at the BBC, building a new breaking news app in time for elections with a cross-team effort of 4 teams in 3 different locations, our main channel of communication was an API contract, and without it, we wouldn't have made it in time. And again, speaking from personal experience at Schwartz IT, we use spec-first API design and have seen some great benefits, including reduced development times, tighter feedback loops, and better API design overall. So all of our backend services at the moment have accompanying spec projects. Currently, most of them are interfaces, but we're slowly moving them to OpenAPI, and we intend to use it for any new projects from the scratch or for the future. Now, your API is your contract. And what is this API contracting? It's a shared articulation of what an API does, both in human and machine-readable format. So it uses a tool such as an OpenAPI to describe requests and responses, basically what your API does. It's something that both API provider and consumer agree upon and get to work developing, delivering, consuming, and integrating, usually for an agreed-upon price. And an API contract helps you mitigate change, or at least it communicates it. So providing an OpenAPI spec before each new version reduces the amount of uncertainty and allows consumers to review your API contract before they commit to it. So that sounds great and all, but there is no way to enforce a contract. People might not keep it. And this can have some monstrous consequences. APIs not being able to talk to each other, etc. If only there was a way and relevant tools to change this. And this is where, enter contract-first development and contract testing and validation comes in. So what is this contract-first development? Contract-first development is about making your intent clear across the team, both internal and external members. By using a tool like OpenAPI, we define our programming APIs clearly at the very outset. Pardon me, just for my throat is running a bit dry. We also update the contract before implementing any changes. So what is this contract testing thing then? Well, this is the way we enforce and govern our APIs. This is the way we enforce our contracts. When compared to traditional end-to-end testing approaches, the contract testing enables you to create consistent curves in your pipeline, an effort that look more like the chart below, while it's maintaining most of the safeties and guarantees of traditional end-to-end tests. Pardon me. So how do I convince you? Well, the main thing that any organization comes to when it comes to software development usually is cost. And when building a product, your time is probably the biggest cost to an organization. There will be an initial overhead in learning how to use contract tests and integrating them into your build pipeline, but using contract tests in conjunction with or as a replacement of traditional end-to-end tests will be cheaper in the long run. Now, we're going to need the right tools for the job. And the first tool we need is an OpenAPI spec. So OpenAPI specification, or formerly known as a Swagger specification, defines a standard description format for APIs. So that's all the available endpoints, parameters, authentication methods, contract information, and can be both in YAML or JSON. Now, here is the anatomy of an OpenAPI spec document written in YAML. Just a very basic example. You've got your path specified, you've got some parameters, responses, and the cool thing is, I think, the schemas, because you normally are returning some kind of an object, and this allows you to describe the object which you're returning. In this case, if it's a pet, it can have an ID, which can be of type integer, or it can have a name, which is of type string, and etc., etc. I think that's pretty cool. And the next tool we need is Swagger. So Swagger is a set of open source tools which are built all around the OpenAPI specifications. Once you have a document, an OpenAPI spec, you can use Swagger to validate your document, to generate clients, servers, and you can use it, most importantly, in the browser to try out the interactive documentation before actually building the API, like in the screenshot which I've provided. And also, what about documentation? So do any of these sound familiar? Code first, meh, documents later, or we'll write the docs when we have time. Almost definitely for sure. maybe. I'm personally guilty of both of these and much more. I've done it before. So the next tool we need is an OpenAPI generator. Now, this is actually the crucial bit of kit which is behind Swagger, which is using the OpenAPI spec that you provide to generate your code. And it's using it to provide API clients, server stubs, documentation, configuration, and probably more. Now, here is an extremely important bit of kit. After spending a lot of time researching how I can do request and response validation for our existing APIs, without having to rewrite all the tests, write a whole new suite of tests, or write a small project or a library to do the work for me, I found the answer. And Atlassian have done it. It's the Atlassian Request Validator, which is a Java library for validating HTTP requests and responses against an OpenAPI specification. It has several modules for different frameworks, and we'll be using the following one for our demo. It's the Swagger Request Validator Rest Assured module, which provides integration with the Rest Assured testing library. Next, we need some tools for the front end. So here's a couple of OpenAPI validators for the front end, which use Express.js, for example, and can validate API requests and responses based on the OpenAPI spec which you provide. These libraries integrate with new and existing front-end API specification. Simply install the vendor and then point it to your OpenAPI spec, and you're pretty much good to go. Just let me get a drink of water. Pardon me. And next, we're going to use all the usual suspects just for our demo, just to get it running. Random wolf fact. So the wolf represents strength, loyalty, family ties, caring, expresses freedom and fortitude. The Japanese word for wolf is okami and means great god. So I think it's a pretty cool animal overall. Demo. So it's demo time. And first, let's go over what I'll try to show you and demonstrate in this demo. We're going to look at an existing OpenAPI spec, and we're going to use it in a combination with an OpenAPI generator to generate a backend in Java and Spring Boot. We're going to use the same spec to generate our frontend in JavaScript and Angular. And then we use Atlassian's validator to validate the backend and our APIs. Then we use Express OpenAPI Validate to validate the frontend and our APIs. And we'll demonstrate how things fail if we breach the contract, if we breach the API specification. So now it's demo time, and I ask you please to bear with me, as this is a live demo, and normally things always go wrong with live demos. So let's see if we can make it. So as always, my IntelliJ. Right, first, so here we have an OpenAPI YAML file. Now, this is an example file provided by OpenAPI themselves, and it's basically describing a basic CRUD application for building an online pet store. Now, it's 800 lines long, so I'm not going to go through it, but basically in this simple demo folder, all we have is this file and the exact same OpenAPI file, but in JSON format. We're going to need both formats because different libraries use different formats. Like I said, the technology isn't quite perfect and isn't quite there yet, but let's see what we can do with them. So let's try out some things. So the first thing that I want to show you is that I'm going to go into the directory. And into the directory, I've got like the two files which I just showed you. And I'm going to ask the OpenAPI generator, and I'm going to pass it the YAML file, and I'm going to ask it to generate a Spring pet store for me. So let's see if that works. And it's done something. And let's see. So if I go into the Spring pet store, I now have a full-blown Java Spring backend application generated just from a YAML file. Let me ignore those profiles for the moment. And if you take a quick look, we've got configuration, we've got APIs, we've got, and we've got models, and you can go through them. And there's, it's automatically generated code. So pretty cool stuff so far. But let's see if this thing actually builds. Let me do a Maven clean install on it. So let's see. Well, this built, and I haven't written a single line of code yet. And let's see if this runs. Any moment now. And if I go into the browser, and if I go to localhost, I see Swagger. Now, things won't be working just yet because it probably needs a Mongo. So it's complaining that I don't have a Mongo database for the backend. But that's OK. We'll get to that part a little bit later. Now, what I want to show you is let's try and do something about the front end. So I'm going to use Angular, and I'm just going to ask it to generate a basic empty project for me. And I will say yes, 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 that's fine. Now, I'm going to quit this because I've got at the moment a lot of proxies and DPNs running on my machine, and this is going to take forever, and it's going to defeat the purpose of the demo. But if I go back to the project, now I've got a front end, and this is the usual Angular app. And there's still not much, like nothing too exciting at the moment. If you think about it, I still haven't used an OpenAPI generator. That's what I'm going to do next. So now I'm using a different OpenAPI generator. Like I said, there are various flavors of them, and I'm using one which is designed for front end. I'm passing the same YAML file, the same that I used to generate the backend, but this time I'm saying that I wanted to generate an API for Angular. I want just the API. So it's done something, and if I go back to my IDE, it has generated a full-blown API, which is like it has a pet, and it has a bunch of other services and models, and it's pretty much like ready to communicate. But we're still missing glue code. We're still missing some of the logic, so because these are basically empty APIs. And what I've done is, because this is a live demo, things go wrong, and we have a limited time. I've generated the exact same two projects from the exact same spec file. We've got the JSON here, and we've got the YAML file here. And the only difference between the things that I've just done now in the previous folder is that I've added a little bit of glue code in terms of the controllers that they can talk to themselves, and a little bit of API tests. So you'll be able to verify this because I'll provide you with some links to GitHub, and you'll be able to check out some of this demo code. By the way, it's not my best code, but it's quick and dirty, and it's just supposed to, serve for demo purposes. So, keep that in mind. Now, before I continue, I just want to run a small Docker container. I just need a Mongo database for my pets, and that seems to be working. And now I'm in the second folder, which is just basically the same two projects generated from the same spec file, but I've given them some glue code so that they can talk to the MongoDB, and they've got like some logic basically behind them, a little bit of glue code. So let me run the backend again. I've stopped it here. Yeah. OK, so now it's running, and we can go and check reload it, and it's still running, and we've got our pet API. Now let's try it out. Or actually, before we try it out, let's go and run the front end as well. So I'm just going to go to the front end, and I'm just going to say run it, serve. So this is going to take a minute. Now, in the meantime, while this is compiling, since my machine is slow today, let's try out the backend API. So I'm going to say I want to try it out, and I'm going to say I want some JSON, and I'm going to say that I'm providing a test animal. In this case, actually, I want to use a different one. And I want to use one which is called Dodge, and it's available. And I'm going to execute this call. So now this is going to execute my backend. And I got a 201, which means it's OK. And if I connect to the database, and if I refresh my connections, I should have a pet database. And this has a couple of animals. Now ignore the first one. That's actually for the tests, so that won't be visible in the online pet store. But now I've got the Dodge, and it's inside my backend database. So my backend is working. Now, by now, the front end hopefully has built, and here it is. So we've got a dog, whose name is Dodge, and is available for purchase. And so far, this is pretty powerful stuff. We've built a front end and a backend just by not writing a lot of code, a little bit of glue code, and pretty much we've generated the whole thing from a single spec document, a single OpenAPI specification. But now here is the innovative bit, which I want to show you. What I've done here as part of the glue code is I've written a couple of API validation tests. And this is the automatic part. This is what I want to be running if I'm doing an integration, if I'm doing a build, or if I'm going to production. So let's run the test. And basically what this test is doing, it's using this JSON, describes my API for the online pet store, and it's testing my code against this document. It's testing my code against the contract, and it's going to tell me if my code is valid, if I've adhered to the document, and if it's working. And the test is passing. It's as you can see, it's reading my document and it's validating my code. And now let's go over a couple of scenarios. Now let's say that the contract changes. So let's say our client or someone brings us a new contract and they're requesting a change. Before I start implementing it, what I can do is I can just run the same test again. Pardon me. And now my test should fail. And yeah, it's failing, and it's telling me, well, there is no such endpoint. You've breached your contract. Basically, your code is breaching the contract. You need to either fix the contract or fix the code, which in this case is what we'll do. But let's say now we go the other way around. So our contract hasn't changed, but as a developer, intentionally or by chance, I make a mistake and I change something in my code. So my API is no longer, it's no longer adhering to the contract. So now if I run the same test again, it should still fail and it should still tell me your code doesn't adhere to the contract. You should go back and fix it. And this is using the Atlassian request validator library. This is using the rest assured. And that's what happened. It's telling me no API path found that matches this. So you need to fix it. Okay, so I fix it in the code, let's say just for an example. And if I run the test again, it should now finally pass and be back to normal. Cool, pretty cool stuff. And now let's do the same thing, but for the front end. So I've got the exact same test just written in JavaScript for the front end. And in this case, it's using a different format. So it's using the YAML file that we have. And if I go back to our application, and if I go here, and if I say npm run test mocha, so this is run my test. I'm using mocha, and it's saying backend should return a valid response, and mock backend should return a valid response. So both of my tests are currently passing. And now let's see what happens if I change the contract. So in theory, the front-end test should fail, and now my front-end should tell me, there's something wrong. You need to go and fix your code or your contract. And this is exactly what happened. And we're going to fix it. And now our test should pass again. And it's the same thing, basically. So I'm not going to repeat it over and over again, but you can do ng test as well. And you can just implement these tests in different ways. But the cool and innovative things is they're using the libraries for validating your APIs. And you can do it for both the front end and the back end. So if we wait for this, hopefully it should tell us, yeah, so all tests are currently passing. Cool. Let me just close this. Right, and you can also use any REST client. So, to just test your API, to test your code. So let's say I've just fired a couple of requests to our backend. And if I go back to our demo, we should have a few more pets. Now we have a cat named Tom, who's also available for adoption. And we have a wolf because we used, wolves in the application. We've got White Fang here. So I hope you found the demo interesting, and I hope you see the benefits and the usefulness of what I'm trying to demonstrate. And I'd like to go back now here. Now, I'll just go over a quick recap of what we achieved in the demo and what I showed you. And while I'm talking, you can use these QR codes or these links to find. I've recorded separate versions of the demo in 2 parts if you want to go slower and if you want to rewatch it. And also there's a link to basically kind of the same code, well, the same code which I showed you just for a demo. So you can play around with it, you can explore it, you can check out the libraries. Again, I've written this code probably in like 5 or 10 minutes, so don't judge me on it. But yeah, check it out. So basically what we did, we used an OpenAPI spec. We didn't write it, but we can edit it. And we used it to generate, well, in a combination with an OpenAPI generator to generate the backend in Java and Spring Boot. We used it with a different generator to generate an API for Angular, for our Angular project. And because we generated them from the same document, from the same contract, the APIs were able to talk to each other. So the code which I wrote was basic logic, but I haven't written any code to make the APIs talk to each other. That was already done for me because I used the same contract. And then we used the Atlassian's validator to validate our backend, and we demonstrated how the test will fail if we breach the API specification, if we breach the contract. And we did the same thing for the front end. We demonstrated how our test will fail if we breach the contract, if we change the code, or if the contract changes as well, which happens. So closing thoughts. I'd like to leave you with some of the lyrics from the song Everything Counts by Depeche Mode. So the handshake seals the contract. From the contract, there is no turning back. The holiday was unpacked. The contract still intact. So people, keep your API contracts intact, you know. References. So there's a bunch of references of everything that I did and everything that I used for the code demo and for the presentation. And next, I'll try to answer some of your questions. But before that, let me start with an icebreaker question. So I've been asked before, can you use OpenAPI for GraphQL? And the short answer is no. So GraphQL breaks REST standards. And GraphQL and REST are competing technologies. And there's, as of now, there is no unique way that you can make them be nice to each other or work together. But GraphQL has its own tools for documentation for their APIs, and so does REST, which is using OpenAPI. So hopefully in the future, people will understand the advantages and disadvantages of both, and will have better judgment of when to use one or the other. But in the meantime, here are a couple of tools that you can use to actually translate an OpenAPI spec to a GraphQL. I'm unaware of other tools that you can use to translate GraphQL in OpenAPI, but I'm not sure that would make much sense. But if you know any of them, let me know. So back to questions, and I'm going to exit my presentation mode just so I can look at the questions in the platform and in the chat. Just bear with me. Okay, so I am available for questions, and I've got a question. Can it work with other libraries than REST Assured? Yes. So the Atlassian library provides a lot of integration with a lot of other stuff like WireMock. Just check out their repo, and there's plenty of other libraries. Any other questions? So let me see. Is it too late to use contract testing if we're not starting from scratch and the project is already built? So no, definitely not. It's much easier to use OpenAPI and contract testing if you're starting from scratch. But what you need to do is probably what we're doing inside the company and inside the team, at least that I'm working or trying to do, is we've got projects which are already running and they're running in the long time. We are just reintroducing it backwards. So we are using the REST Assured library the same way that I showed you, and we're just rewriting tests or writing new ones. And we're introducing something so that we have some security and validation for our APIs based on OpenAPI specs. In fact, I recently received, as part of a Jira ticket, attached an OpenAPI YAML from an external team, and I used it for development. So no, definitely not too not too late to start. Are there any questions? Let me see. Will you share slides of the event? I don't know about that. Just let me know if I'm not seeing any questions. Okay, so I am not seeing any more questions. And because of that, there is actually, I prepared a bit of a bonus because I thought that we might have a bit more time. First of all, I'd like to show you the context of our company, Schwartz. If you like what you saw and you're keen on using OpenAPI and other cool technologies, contact our HR and see if you can find a match. And also, before we say goodbye, so just this morning, a friend of mine a very close friend who knew that I'm talking about APIs, sent me this, and I thought it's pretty cool to share it with you guys. So it's a song, a video clip of this guy, by this guy, Dylan Beatty, who's a developer and a musician. And it's a parody of You Give Love a Bad Name by Bon Jovi. And I think it's really, really applicable to what I just said because of the lyrics. You say it works in a RESTful way, then your errors come back as 200 OK. And also you promise me JSON, then send XML. So just for quick fun, let's check it out. And I'll check as well if you have some more questions while we're looking at this. Oh, come on. So let's go back to our browser, and I'm hoping that you can hear it. But of course, YouTube commercials. What can we do about them? But yeah, I think the lyrics were really cool. So I'm going to stop it here, and I just wanted to tell you, people use API contracts. Don't make your API a wall of shame, and don't give REST a bad name like it was just sung in the songs. So that's it for me. Thank you very much for your attention. I hope you found it useful and entertaining, and I hope that you get to use this technology, you develop it, and I look forward to hearing about it from you guys as well. Thank you.